I think the biggest opportunities are not in the small seed rounds, but in people who are building foundation models that will unlock big categories. Language models today are trained on text, math, and coding data. It turns out that if you scale the MOE architecture on math, coding, and text data, you make them really powerful coders. But it turns out that it's not very useful towards scientific experimentation.
Brian, welcome to Venture Grounds. We're super happy to have you here.
Yeah, thank you for having me here.
Of course. Let's get straight into it. Tell us how you decided to invest in Recursive and your general investment philosophy.
Yeah. So we are very thematic in our investing. Um, in 2023, I backed Skilled, which was building the ChatGPT moment for robotics. In 2024, our thesis was in reinforcement learning being the pathway for agents, and so we backed Reflection AI. In 2025, my most recent investment was in Periodic Labs, which was driven on a thesis about AI for science. One of the biggest focuses, which we should definitely elaborate on later, is that the next frontier is AI in the physical world. And our investment in recursive intelligence is a belief that AI for the digital world is getting saturated by the big labs, and a great frontier for new startups is bringing AI into the physical world and enabling us to do things like chip design a lot faster. And that is part of what made us so excited about recursive intelligence.
Amazing. What other, maybe tell me about what AI for science actually means. Like, what are some of the, use cases or specific areas within, science can mean so many things
Yeah.
that you're particularly fascinated by?
Like AI is like just transformed everything we do on our laptops. Today I just go to my web browser and I tell the agent to fill in the spreadsheet for me and it does it for me, right? Like every day, it's like I have many conversations with ChatGPT. But like, how do we make AI useful for scientific experimentation? Our general philosophy is that AI can enable us to run scientific experimentation 100 times faster. And I think we're, in the landscape, like I do think in the future, we might think of like going to the pharmacy and getting a generic drug as a very archaic practice. We might just give our DNA sample and get a custom drug specifically tailored for us, right? In the material science world, I do think that we will use AI to speed up scientific experimentation by 100x, and we'll be able to discover things like room temperature superconductors. And I think energy is another like domain where like the AI can really revolutionize what we're seeing today, right? Like, for example, in the energy space, we might be discovering new materials to create solar panels with. There are just so many, like today AI is not really tailored towards scientific experimentation, because you need to train the AI architecture on to understand like how electrons interact, to understand how drugs interact with proteins, interact with the human's cellular system. And I think once we train the AI not on text data, but scale the MOE architecture towards scientific data, whether it's bio data, where there's materials data, we will be seeing AI unlock very meaningful scientific breakthroughs.
Yeah, so what are the sort of primary bottlenecks to achieving these sort of like science-driven or physical kind of AI models? Is it sort of the sort of model and architecture layer? Is it fundamentally a data collection problem? Like, where do you see the biggest opportunities when it comes to going beyond the language models?
I I think that the language models today are trained on text, math, and coding data. We have like it turns out that if you scale the MOE architecture on math, coding, and text data, you make them really powerful coders. But it turns out that it's not very useful towards scientific experimentation. We have seen multimodal models advance quite significantly. And so, like, if we train decoders to learn how to parse through scientific experiments, and we train a model on tokens of scientific data rather than like text, math, and coding data, it turns out that we are able to train models to like understand how like towards doing scientific experimentation. You know, like AlphaFold is the perfect example where we can actually where we trained a model on protein folds and we're able to predict new protein folds, right? And I think that we have only explored the cusp of what is possible today.
Do you think that exploration is driven by sort of like short-term technical limitations, or is it a capital allocation problem? Like, how do you see that particular space within AI kind of advancing forward?
Definitely a capital allocation problem. You know, like like the scaling architecture that led to the reasoning models like O1 and so forth. That has it is expensive it's expensive, right? Like these models cost hundreds of millions of dollars to train.
Yep.
When you factor in the experimentation costs, and we just haven't really spent the money to train models like specifically tailored towards discovering specific materials, right? We haven't really scaled out like like bio foundation models yet, but I think that when we do, these models will discover quite meaningful breakthroughs. You know, like the reason that like, you know, in March, right, the DeepSeek paper came out and it was such a big breakthrough, and really like the reason that the DeepSeek paper was such a big breakthrough was because it described how to train a reasoning model, right? They basically talked about like the big breakthrough idea was using group relative policy optimization, like GRPO, and how to leverage that to train a reasoning models. And now that this knowledge is democratized, I think that we are seeing teams apply this exact approach towards scientific models to accelerate scientific discovery. Now, one caveat I would like to point out is that models can speed up scientific experimentation up to the wet lab automation phase. But once it comes to like actually executing physical experiments, that is definitely still a bottleneck that it's just not necessarily cost feasible, right? But there is just so much that we can accelerate up until that stage.
Makes sense. And, you know, I imagine that investing at that layer of innovation is a lot less noisy than, say, at the app layer.
Yeah.
Just simply because of the quantity of folks building an app layer.
Yeah.
Probably there's a more tried and true playbook for that.
Absolutely.
How are you sort of identifying the teams that you're backing and deciding which ones to allocate to?
We are very thematically driven, and so within the domains that we have decided to invest into, which right now is like in the AI for science space, in the AI agents space, we really look for who are the people who are producing the biggest breakthroughs in the field, right? Like for example, recursive intelligence, the founders were the creators of AlphaChip. With our most recent investment in Edison, which is a commercial entity that spun out of Future House, they were always known as one of the leading labs in AI for bio, right? Like we rarely take inbound. We are outbounding towards the very best people in fields that we are excited about, based on research that we think is ready to be commercialized. You know, we have reached out to in the past. You know, we reached out to Misha and Giannis about commercializing like reinforcement learning for agents when we felt that like we were ready to hit the AlphaGo moment for AI agents. We had reached out to Deepak, the founder of Skilled, who when we felt that it was the right time to scale VLA models to achieve this ChatGPT moment for robotics. Whenever we feel like the research is there in trillion-dollar categories, we approach the founders and we come with a prepared mindset, ready to invest up to $30 million.
Awesome. That's awesome. I'm going to pivot to slightly different subject matter now. I think you've said in the past that agents aren't useful yet. Um, Given how many agentic startups exist out in the world, it's a bit of a bold statement. Do you care to maybe elaborate on what you mean by that?
Yeah. Well, I would say that the caveat is AI agents are definitely useful today, right? That was why companies like Harvey are delivering like so much revenue. But I think that we have overhyped what agents are capable of. Today, using AI agents is not a very smooth process. It's not like just going to ChatGPT and you're talking to a chatbot that knows everything. In terms of the big gaps for AI agents, I would say there's plenty of things that AI agents are not capable of solving, primarily because they lack multimodal understanding. They're bad at multi-turn reasoning. They importantly don't have access to the organizational knowledge in which they are operating in, so they often operate with lack of context. And fourth is they don't really have continual learning. They don't really remember everything that they see. I think that there is very interesting research happening in each of those domains, right? For example, how do we do multi-turn RL? How do we make multimodal tokens useful towards the general intelligence of models? What are some of the new model architectures that can enable models to do online learning, to do continual learning, right? And once we have made these unlocks, which I think will happen over the next 5 to 10 years, I think we will see AI agents being as seamless as ChatGPT is today. And at that point, we will see agents like AI just truly automate digital knowledge work in a way that none of us are imagining today.
Double clicking on that, do you think that companies, you mentioned Harvey as an example of one where obviously you can deliver value at sort of a scale which permits potentially, venture returns with the level of sort of technological sophistication that we have today. Do you think it makes sense for folks to start commercializing sort of agent driven solutions and sort of develop or grow their product capabilities over time as the tech gets better, or is it sort of a wait and play later situation?
I think a lot of companies are, like whether it's Harvey, whether it's Sierra, are discovering niches that agents are able to solve. And today it requires a lot of like custom setup, and it requires a very specific descriptions of the domains that they are able to solve. But imagine once we have solved continual learning, right? Imagine when agents just remember everything they see and learn how to adapt based on that. Once we have achieved that point, you'll just see we will have general purpose agents, right? And the startups that unlock this will be incredibly valuable platform players. And so it's not like, I think the existing companies are fantastic. They've built great technology. They're delivering great revenue. I think they will see great IPOs. But I think in the next 5 to 10 years, we are just going to completely reimagine what is possible today.
It almost sounds like they may be interim solutions that at some point 5 to 10 years down the line a general purpose solution will potentially make it irrelevant.
Potentially, right? Like if you look at like what is happening in the OpenAI models today, they're going back through their training data that they have inputted into the models, and they're discovering that instead of having humans label the training data, actually if they have an AI go back and relabel the training data, they're seeing orders of magnitude improvements to their models. And I think that brings it into question. Like today we say a lot of the AI agent players have a huge moat in the data that they have, that's labeled by humans. Well, I do imagine a future where models become more powerful labelers than humans are. And maybe like all the pre-existing data that the existing companies have might not turn out to be as big of a moat as people think, right? And that is why I'm still so excited about new AI agent startups.
Yep. Makes sense. Very cool. Um, you know, maybe just stepping back, give us a broader sense of how, again, you're evaluating founders in these technical spaces. Obviously, they're coming from some of these, established companies or known sort of like research entities. But what else matters to you when you're really thinking about backing a founder or a team?
There's three big things. Well, like the most important overarching theme is it has to be in a category where we think the tech is ready and where we think they're going after $1 trillion category, especially in this day, because rounds have become bigger than they have ever been before. But then within those domains, like AI for science, AI agents, robotics, where we think that there is truly like the $1 trillion potential, there's three big things that we look for. One is founder market fit. The founder needs to live and breathe the space. The founder needs to be irrationally dedicated to making this domain happen. Like when the founders of Reflection, Misha and Giannis, they were not new to the reinforcement learning for agent space, right? They were the people who were like founding engineers of DeepMind, who had unlocked some of the biggest RL breakthroughs, whether it's DQN, AlphaGo, AlphaZero, and so forth. Like reinforcement learning was their domain, and this was the time to apply RL towards agents. Number two is the market size. We're no longer in the era where we're investing in companies that will just get to 150 million of revenue in an IPO, right? We're looking for companies that will deliver OpenAI scale revenue. Number three is that there's a catalyst that will make the domain happen. And that is why, like, we are very specific about what we're investing into, right? For example, in AI for science, we're not investing in web app automation because the space is still quite premature. But we are investing in like using AI to speed up scientific experimentation. Like AI that can run experiments in silico can speed up humans quite significantly when it comes to creating like towards drug discovery, for example.
Yeah.
And so, yeah, just that there is a catalyst and the tech is ready.
Yeah, makes a ton of sense. Do you have any like messages to technical founders who might be interested in getting in touch with you?
Like, yeah, I mean, if you have a bold vision and you think you are among the best in the field, we are ready to chat, and we are bold with our check sizes.
Amazing. Okay, we're moving into our espresso sort of rapid question round. First question, what is one view you hold about the market that most investors would disagree with?
I would say that it is fine to invest big checks up to $30 million at the seed round.
Cool.
The average seed checks are still $3 to $5 million today.
What is one sort of thesis or area of conviction that you completely have rethought in the last year?
That's a spicy one. I think AI for scientific discovery. There's big breakthroughs across every domain, like GNOME in the DeepMind chemistry team. Isomorphic Labs is like truly delivering revenue scale with some of their partnerships. I think AI for science is seeing meaningful breakthroughs that are monetizing.
Cool. What is a risk that most of VC is sleepwalking past right now?
I would say that I think the biggest opportunities are not in the small seed rounds anymore, but in people who are building foundation models that will unlock big categories. I think, in retrospect, companies like OpenAI, Anthropic, Reflection, Skilled, Periodic Labs, like these are the kinds of companies that will unlock true venture scale returns.
What is a company or founder that you're totally fascinated by at the moment, right now, and why? Doesn't have to be in the portfolio.
I am incredibly excited about recursive.
Cool.
I, you know, etched AI is currently a unicorn. And I just think that recursive intelligence is building the infrastructure that can spawn many such unicorns. Alpha chip is one of the big reasons why TPUs are so effective. And I'm so excited to see this technology democratized.
Amazing. And then what is a founder red flag that is actually green flag for you?
I would say irrational boldness. I like founders who dream big.
Cool. And what do founders consistently get wrong about what VCs actually do?
I think a lot of founders think that VCs are just running around meeting people. I spend half of my time reading papers and being up to date on what's happening at the frontier. I think we actually read and think a lot more than founders think we do.
Refreshing. Um, that's all of our questions. So I've really enjoyed learning so much on the podcast today, and thank you so much for joining.
Yeah, thank you for having me.
Of course.